Hi, I'm Krishna, and this is day 5 of 30 days of understanding the modern AI stack. So, in this video, I'm going to explain something that every beginner misunderstands. Why a model is a genius during training, but a complete idiot during testing. The answer: regularization. So, let me open up your mind to something, guys. Guys, imagine I give you a textbook with the answers highlighted. You score 100 on the test. You feel smart. Now, I take away the textbook and give you a fresh question. Suddenly, you are not brilliant anymore because you didn't learn the pattern. You memorized the page. This is exactly what happens to neural networks without regularization. They become A plus students on training data and complete dropouts on new examples. So, what regularization actually does? It is not some magical verb. It's simply a way of telling the model, please don't memorize, learn the real pattern. And it does this by adding a penalty whenever the model tries to become unnecessarily complicated. Think of it like this: the loss function says, reduce errors. Regularization adds, but don't cheat. Now I know what you are thinking, how it works under the hood. Inside a neural network, every weight is a knob. The model tries to turn thousands, sometimes billions and trillions of knobs to make training loss as small as possible. But it turns some knobs too aggressively. It begins fitting noise in the training data, weird outliers, random quirks, rare exceptions. This is memorization, not intelligence. Regularization steps in and says, hey, if you twist those knobs too much, I'm adding extra loss. Stays simple, boss. This keeps the model shape smooth rather than overfitted. And there are so many regularization techniques now because there isn't one way models cheat. They cheat in different forms. Sometimes they rely too heavily on one neuron, sometimes weights blow up, sometimes they overfocus on rare samples, sometimes they need more data variety, sometimes they just train too long. So we invented different guards for different cheating strategies. Think of it like security systems. L2 keeps weights in check. Dropout disables some neurons so no teacher's pet gets too smart. Early stalking stops the exam when you start cheating. Data augmentation gives you more examples so memorization becomes impossible. Label smoothing prevents overconfidence. Patch norm layer norm keeps thought clean and stable. Each solves a different way models go wrong. And now I'm thinking, how did people come up with this? Honestly, by suffering. हिंदी वाला सफ़र नहीं, अंग्रेजी वाला. Early neural networks overfit so badly, researchers spent years fighting it. Some idea came from statistics, some came from biology, some came from pure trial and error. Robot literally came from the idea, what if we just randomly shut down neurons? Would that force the network to spread out its learning? It did, and it became one of the most successful regularization tools ever. So do ChatGPT, Gemini, image tool, video tools use this? Yes. Every single large model today heavily relies on regularization, but at scale. Transformers use ADAM-W, Adam with L2, dropout in attention layers, layer norm everywhere, label smoothing in older models, data augmentation, massive data augmentation for vision, stochastic depth in deep models. Without these, training a large model would collapse. So, which regularization should you use? I would say it's best to start with ADAM-W, great default, stable, used in transformers. Add dropout if you're using dense layers, prevents co-adaptation. Add data augmentation if your dataset is small. More variety, less memorization. Use early stopping if training loss dives but test loss rises. Stops memorization in real time. You don't need all of them. You need the right ones for your problem. So find an analogy to seal the understanding. Regularization is like teaching someone to drive. You want them to learn the rules, not memorize a single route. If they memorize the route, they fail anywhere else. If they learn the patterns, they can drive anywhere. Regularization forces the model to learn patterns, not pages. If you understood this, you now understand why good AI feels so robust and bad AI feels so dumb. In the next video, we'll go into initialization and why choosing the right starting point can make the difference between a model that learns and a model that never wakes up. See you in the next video. Let's do it.